Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2018, 10B, Problem 12, and it deals with geometry. I hope you guys enjoy this video and let's get started. The problem states, line segment AB is the diameter of a circle with AB equals 24. Point C, not equal to A or B, lies on the circle. As point C moves around the circle, the centroid of triangle ABC traces out a closed curve missing 2 points. To the nearest positive integer, what is the area of the region bounded by this curve? So we can begin this problem by just sketching out what we are given. So it tells us that we have a circle and line AB is the diameter of the circle. And so the length of AB is 24. Point C, it's not on A or B, or not equal to A or B, lies on the circle. And as it moves, it traces out a closed curve. So I'm just going to let C be, for example, right here. And then we'll get a triangle. It says triangle ABC. The centroid is the center of the triangle. So for example, this point right here, I'm just going to let this, I'm just going to name this G. That's going to be the centroid, which is the center of the circle. So essentially, as you move C, point G is going to trace out a closed curve. So across from it, it's going to move, and then across from it, over here, it's also going to be G. And then, for example, I'm just going to let C be right here. So that's going to be C1, C2, G1, G2. So technically, we see that we have two triangles when you move C along. Well, we know that angle C is 90 degrees by inscribed angle theorem. And so its circumcenter is the midpoint of AB, because a circumcenter is basically the point where the perpendicular bisectors of the sides of a triangle intersect. And so for a right triangle, it's exactly the midpoint of the hypotenuse. So this is going to be the circumcenter, and it has a property which states that the circumcenter is always equal distance from all vertices of the triangle. And so I'm just going to let this circumcenter be O, for example. That means that AO equals to OB, which is equal to OC. And because O splits the line AB in half, we know that OC is equal to 12. So essentially what we want to do is we basically want to find what is OG. Because if you see this is a circle, it tells us that it traces out a closed curve missing 2 points. So technically these would be the two missing points that we don't know. And we want to find the area of this curve. So if we find out what OG is, that is the radius, and then we can just use pi r squared to find out the area. Well, we know that OC is 12. And in any triangle, the centroid, which is G in this case, it divides each median into parts in the ratio of 2 to 1. So basically what I mean is the distance from a triangle's vertex, for example, C right here, this is a vertex, the distance from here to the centroid is 2 times as long as the distance from the centroid to the midpoint of the opposite side. So basically this line right here, this is 2x, and then right here is x. Well, given this information, we can figure out that OG is equal to 1/3 OC, which is 1/3 of 12, which is 4. So now we know that the radius is 4, and then we can just plug this into the circle area formula, which is pi r squared, to get 16 pi. And this is around 50. So the answer is C, 50.